How to use Kirchhoff's voltage law. So Kirchhoff voltage law, the sum of the voltage rise around a closed path will always equal the sum of voltage drops. Here an example. The first one, we need to define closed path, draw the loop direction as the reference. Always we draw the clockwise. So in this circuit, we only have one closed path, so definitely we just draw the clockwise, the loop direction. Step 2, make sure the voltage polarity of each component. In this circuit, there's 4 components. The other 3 have a polarity on it, but for the fourth one, the Vx no polarity, so we can assume one polarity for it. Give the polarity here, then go to the step 3. Determine each voltage as the voltage rise or voltage drops. So what is voltage rise mean? So here's the example. This direction represents the loop direction and the polarity on it. When the loop direction pointed from the negative to the positive, at this time we say this voltage is voltage rise. That means from lower to higher. Another one is voltage drops. A voltage drop, such like this one, the loop direction pointed from the positive to negative, from higher to lower, so this voltage is voltage drop. So according to this, we can define each of the voltage rise or drops. So here you see the loop direction here, pointed from negative to positive, so this is voltage rise. And for this, the 7 volt, the component, the loop direction here pointed from positive to negative, so this voltage is voltage drop. For the Vx, the loop direction pointed from negative to positive, so this is the voltage rise. The next one, the loop direction pointed from the positive to negative, so this is voltage drops. So now we determine all the voltage rise or voltage drops. Step 4, we list the KVL equation. The KVL equation means the sum of the voltage rise equal the sum of voltage drops. So we list all the voltage rise on the left side and the sum of all the voltage drops on the right side. This is the KVL equation. Then we solve it. We can calculate Vx equals 7 plus 9 minus 5 equal 11 volt. Okay, so that's the 5 steps for using Kirchhoff's voltage law. The next example. Determine the unknown voltage VAB. First, define a closed path. So here you see for the VAB in the middle, so we can choose the left side, the loop direction, and the closed path. Make sure the voltage polarity of each component. So all in this loop, we have 1, 2, 3 components. So there's 3 voltage polarity all already there. For the voltage supply, the positive, negative, and then determine each one as the voltage rise or voltage drops. So this one, loop direction pointed from positive to negative, so this is voltage drop. For the VAB, the loop direction pointed from high to low, so this is the voltage drop. And for the E, the loop direction pointed from negative to positive, so this is voltage rise. Okay, now the 4 steps list the KVL equation. The voltage rise equal the voltage drops. So 15 equals 6 plus VAB. Then we solve it. VAB equals 15 minus 6 equals 9 volt. Also, we can use another side as the closed path. So you see, we can use the blue color, the loop direction. Under this condition, so the VAB at this time, the loop direction pointed from negative to positive. So this is the voltage rise. For the 4 volt is pointed from high to low, so we say the voltage drops. And for the 5 volt, it's also from positive to negative, so it's voltage drops. Now we can list the KVL equation. VAB equals 4 plus 5. Then we solve it, equal VAB equals 9 volt. We see this same result to the first one. The next example. We need to find the unknown voltages V1, V2, and V3. So we choose the loop 1, the loop direction, and we find it voltage rise. This is the voltage rise. This 10 volt pointed from positive to negative, the voltage drops. And the 12 volt pointed from negative to the positive, so this voltage rise. And for the V1 pointed from high to low, so this the voltage drop. This also pointed from high to low, so this voltage drops. So then we list the equation. Voltage rise, 12 volt plus 8 volt equal the voltage drops, 10 volt, V1, and 4 volt. So then we solve it. V1 equals 20 minus 14 equals 6. So for the second loop, the loop direction like this. So at this time, the 12 volt voltage drop from high to low. So for the 16 volt, it's from low to high, so it's voltage rise. For the 15, the loop direction pointed from high to low, so this voltage drop. For the V2, is pointed from negative to positive, so it's a voltage rise. So according to this, we list the KVL equation. The sum of the voltage rise equals the sum of the voltage drops. So voltage rise 16 and V2. Voltage drops to 12 and 15. Then we solve it. V2 equals 12 plus 15 minus 16 equals 11 volt. So we solve the second path. So for the third path, we use the other color to draw the loop direction in clockwise. So according to this loop direction, you see for this time for the V2, that's from positive to negative, so this voltage drop. For the 6, this voltage drops. For the 7 volt, pointed from negative to positive, is voltage rise. So for this V3, pointed from high to low, so this is voltage drop. For the 5 volt, is pointed from low to high, so this is voltage rise. And for the V1, pointed from low to high, is voltage rise. So till now we find all the voltage rise and voltage drops. So then we list the KVL equation. V1, the voltage rise, plus the 7 volt plus 5 volt, all the voltage rise, then equal the drops, voltage drops. So then we substitute the V2 and V1 from the former result. So finally we can solve it. We get the V3 equal the 18 minus 17 equal 1 volt. So now you see this the method how to use the KVL, follow the 5 steps. You can easily to use it. Thank you for watching. Welcome to visit our website, and there are a lot of exercise for you.